Welcome to the second video on this section on the periodic table. And in this video, we're going to deal with the basics of the periodic table. So you guys are used to seeing the periodic table. It looks like a grid, but there's a lot more to it than it just being a grid. First of all, we need to define what is meant by periodic. And periodic or periodicity is a pattern that recurs at specific intervals. It is a cyclical pattern. And one of the best examples of a periodic function is a sine wave. It goes up, down, up, down, up, down, and it repeats in a very definitive manner. Magazines are frequently called periodicals. If you happen to get People magazine, you get it on Saturday. Then the following Saturday, you get another one. And then the following Saturday, another one. And the following Saturday, another one. And you would call that a periodic pattern, and you would say the period here is 7 days. This is different than newspapers. Newspapers are not periodic. You get one on Sunday, and Monday, and Tuesday, and Wednesday, and Thursday, so on and so forth. You get one every single day. There's no repeating pattern or change. It's just a consistent value. So going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ad infinitum is not periodic. Going 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, that's periodic. For those of you that are musically inclined, the scales A, B, C, D, E, F, G, A, B, C, D, E, F, G is also a periodic pattern. So now we take a look at the periodic table of the elements. You'll see why in a later lecture why this is called periodic. Today's lecture just focuses on some of the basics of the periodic table. And there are multiple forms of the periodic table. This is the one we use. It was devised by Glenn Seaborg, and this was so important that along with his other accomplishments, Glenn Seaborg had an element named after him, 106 Seaborgium, and he's the only person to have an element named for him while he was still living. So let's take a look at the periodic table. As I said, the first thing you notice is that it looks like a grid, though it's somewhat of a split grid. And you may ask, why are the two lower rows separate from the top? And that's because these actually belong over here where you see the words lanthanides and actinides. The periodic table should be split here, spread, and so in actuality, this is what it really looks like. But this is way too big to put on a sheet of paper to make it easy for people to use. So those are separated out. Now, the rows are called periods. So each row is a period. And columns are called groups. And all groups have similar chemistries. That's why they're called families sometimes, because they're similar. And you'll find out in a later lecture why that occurs. Now, if you take a look at your periodic table, you will notice towards the right side, there is a heavy black line that I'm going to call the staircase. This is a dividing point. Everything to the left of the staircase are called metals. Metals have a certain set of properties. They are solid at room temperature, except for mercury. They conduct electricity. They conduct heat. They are ductile, able to be drawn into wires. They are malleable, easily bent, easily pounded into thin layers. There's actually a listing in your handout of the various properties. Everything to the left are the metals. Everything to the right of the staircase are the nonmetals. These are, as you'd expect, pretty much the opposite of metals. At room temperature, 25 degrees Celsius, they can be solids, liquids, or gases, depends upon what the element is. Most of them are poor conductors of electricity. Most of them are poor conductors of heat, so on and so forth. And then right along the staircase, there's an interesting group of elements, and these are called the metalloids. And the metalloids, depending upon what you do with them, can have the property of metals or the property of nonmetals. And probably the classic metalloid is silicon. Silicon by itself is a poor conductor of electricity, poor conductor of heat. But if you take pure silicon and add just a little bit of germanium or arsenic, not a whole lot, all of a sudden the silicon now becomes an excellent conductor of electricity, and this is why all of our devices and our computers have silicon chips. Now, going back to a totally clean periodic table, you can sort of see a pattern. Over on the far left, there are 2 tall columns. Over on the far right, there are 6 tall columns. Then you have this collection in the middle between those 2 sets of tall columns. And then you have the set of elements that are separated to the side. The 2 tall columns on the left is called S block. The 6 tall columns on the right, those elements are in what is called the P block. And the S block and the P block elements are called representative elements. The elements between the S block and the P block are called the transition metals, and the elements that are separated out are called the rare earth metals. Additionally, some of the groups have specific names. So the first tall column here, these are called the alkali metals. They all have similar chemistries, and they react in similar manners, but not quite the same. But this group is called the alkali metals. The last column is called the noble gases. These are highly unreactive, but you can get a couple of them to react, but they are the noble gases. The column next to the noble gases, starting with fluorine, going down to astatine, these are called the halogens. Lastly, the second tall column on the left, starting with beryllium and going down to radium, those are known as the alkali earth metals. So these are commonly used in the textbook and in videos and just in talking in chemistry. So you need to know the alkali metals, the alkali earth metals, the halogens, which are sometimes called halides, and the noble gases. So to review, rows are called periods on the periodic table. Columns are groups. To the left of the staircase, we have the metals. To the right of the staircase, we have nonmetals. And on the staircase, we have the metalloids. The first tall column are the alkali metals. The second tall column are the alkaline earth metals. The second to last tall column are the halogens. The last tall column are the noble gases. The first 2 columns is the S block. The last 6 columns is the P block. The S block and the P block are known as the representative elements. The elements in the 10 columns between the S block and the P block are called the D block, or transition metals. And the 14 columns separated from the periodic table are known as the F block, or the rare earth metals. So this should allow you to leap into the periodic table. The next video by a gentleman out of Bozeman, Montana, will explain the idea of periodicity on the periodic table, and then we'll continue from there.